Okay, guys, hi. We're probably going to start kind of now today, but we can also decide on do we want it to start sharp or in 15 minutes? How do you feel? Like, who is for starting at 10 sharp generally? Who is for 10:15? Okay, then 10:15 it is from now on. But it's fine to start today, right? Or do you want the 10 minutes to just hang out and chat? Fine? We start? Okay, good. So as you might have seen, there is a camera. Everything is going to be recorded. So I'm not here to record you. I'm here to record me. And it's also for you because it's going to be on eCampus and on YouTube. So it's very easy for you to go back to the lecture and find out what worked, what not. If I say something that is not on the slides, it's harder to forget it. The course will be in English. I understand that there is a bunch of people here who speak only English, and I'm much better in English than in German, so that's why it's going to be in English. Hope nobody has problems in it. But if you have any questions at any point of time, the light went off, okay. If you have any questions at any point of time, then just ask it in any language, it's fine. So if you are more comfortable with English, do it in English. In German, also fine. If you've looked at the eCampus course and saw that it's empty, it's not because of me, it's because of the system. It takes some time to set up the course, and it's not set up just yet, so I'm sorry for that. We're going to fix that at some point. Right, so let's try to, and one more important thing, questions are welcome. If at any point of time you don't understand something and feel like something is unclear or I'm wrong or something, just raise a hand, say it, it's very open here. So you don't have to just sit here and kind of swallow all your pride and then afterwards figure it out on your own. No, it's a discussion. If something is unclear, it's my failure, okay? Good, so we're going to start, and you might see that there is modern in the first word of this course, and therefore a question who knows a bit of C++, who's ever worked in C++? Is there anybody who did it? Sure, okay, 1, 2, okay, good. Any other programming languages I know that some people have to learn Java, so who did Java at least a bit? I don't ask if you're experts. Okay, good. That's actually pretty good. Python? Okay, got it. So Java is kind of the main base for us, and we're going to start from there. So modern, we will talk about it, but it's not going to be the typical C++ course where we start with C. It should be easy. It should be simple because C++ has changed in the recent years, and this course is targeting this changed C++. All right, so today, this is actually the outline for today's and probably tomorrow's lecture. We probably will break it up somewhere in the middle today, and I'm going to introduce the course. What is the course about? What are we going to do here? And we are all going to work in Linux or in any Unix system. I see somebody has a Mac. That's also completely fine. After introducing Linux and how to work with the terminal and so on, we're going to dive into C++ syntax and start with the basics, all the what is a variable and so on. And in the end of tomorrow's lecture, I will tell you how is the submission of homeworks going to be done. Okay. So let's start with this. What will you learn in the course? Why are you here? So the main idea would be that you will learn how to work in Linux, and you will learn how to write software in modern C++. So it means that it's going to be safe, it's going to be memory safe, and it's going to run fast. There are also going to be some core software development techniques, like which tools to use, how to use them, and what can make you a better programmer overall, not just in C++, but generally. In the end, after we're done with the C++ part, we will also dive into OpenCV for computer vision and image processing. OpenCV is a library. You're going to learn how to work with this library. It's kind of the industry standard. If you don't want to implement something on your own, even companies use OpenCV for their day-to-day workflow. You will learn how to implement inverse image search. So inverse image search is, probably it's easier if I just show an example. Of course, there is no internet. Sure, I will not show you an example now, I guess, if there is no cable. There is a cable. Maybe I will show it here. Let's give it a sec. No, okay. Yeah, sorry, that I didn't think through. Anyway, the inverse image search is you can drop in an image now, for instance, in Google search, and it will find you images that look similar. It has never seen an image that you put it in there, but it will still find similar images. And that's what you will learn how to implement yourself, like a very basic version of it, the original implementation of this feature, but I find it still pretty cool. I did it as my project when I was a student, when I was a master's student. It was really fun, and for now we had only positive experience of other students who did that. Okay, there are maybe some questions. Why is it C++? Why not Python? Why not like use other language? Why we use Linux? Why can't we do it on Windows or Macs or whatever? And basically the idea is that, so first of all, C++ is an extremely popular language. Like it's, there are a couple of surveys. One of them done by C-Line. So JetBrains is a company. It's a Russian company, but they're actually pretty good. And they did a survey, and they said that there is more than 4.5 million people using C++ professionally, so professional developers. And there is a huge shortage of C++ programmers. So if you know C++, you will land a job at top companies easily. I've worked in the Silicon Valley, and everybody needs C++ there, for instance. And looking for jobs in Germany, also C++ is, if you know it, you will easily land a job. They're also like, Linux is on the rise now. Before it was mostly Windows world for desktop programming. Now Linux is on a huge rise. So for instance, in the latest survey of Stack Overflow, hopefully, who knows Stack Overflow? Okay, good. You all have to know Stack Overflow. Like that's basic programmer's tool, like at least for the start. So they did a survey, and it's a huge platform. Everybody uses it. So this survey is kind of trustable. And now half of the developers use Linux, and Linux is a much nicer system to use when you're programming, at least from my perspective now. And why C++ 11? So C++ 11 is when C++ became, again, a modern language. C++ has a huge history. It was built from C in 70s something. I don't remember the exact year. And it got to be like a monster. Like, so people are afraid of C++. People don't know how to write code in it because it's very scary. And in C++ 11 is a completely different language. I believe it should be taught in a different way, and that's what we're going to focus here. Good. So the course will be broken up in two parts, which is something that I already told you a bit. So the first part is this. It will consist of lectures and homeworks. So there's going to be 5 homeworks, 10 points each. And if you gain 25, you will kind of get to the other part. So you can't go to the other part if you don't get at least half of the points for the homework. And the second part, which you can get to after all the homeworks, is the fun part where you are doing the project on your own. So you are divided in groups of 2 to 3 persons, and you do a project together. So all the project is carried out completely on your own. There is no code given to you. There is a brief introduction to OpenCV, but then you're on your own. Of course, I'm there for any of your questions and to help you if you get stuck, but all the project planning and project carrying out is on you. And the exam is you need to present the project to me and Professor Stachnis orally. So you just come in, show the project, say how we point into the code or into the like we ask how did you implement this feature and that feature, and you need to be fluent in that. So you won't need to know like how many bytes are an integer type or something like this. There's not going to be obscure questions like that. It's going to be very practical. Good, so this course comes with batteries included, so everything should be in. We will give you an Ubuntu virtual machine to all the people who don't want to install Linux, although I would recommend you to install Linux on a real system. At first it might be a bit daunting, but when you get used to it, you can't really go back. Again, like if you have something like a Mac, it's a Unix system, I guess you can just work in it. Another alternative is Windows has rolled out this subsystem, Linux subsystem for Windows, and you can kind of install Ubuntu within Windows. I briefly tried it. I'm not going to provide much help with it, but it seems to work. Okay, so as I told you, lectures hopefully will be recorded if nothing goes wrong, and you will get the recording of every lecture on YouTube and eCampus. And we also have a Git server, so you will learn what Git is too. Like in case you don't know, it's a version control system. You will be able to upload your code on our server, which is in-house in that building. And it's also a tool that is kind of mandatory for modern programming nowadays. Okay, good. So let's start with Linux. Like Linux, very briefly and very coarsely, is a Unix-based system. Unix is just type of kind of architecture of the system. The Linux kernel is implemented by Linus Torvalds. It's not very important for you, but I think it's kind of important to say, to credit the guy another time. He still maintains the core developments of the Linux kernel. So that's that. It is extremely popular, so don't think that it's some obscure system that nobody uses. If you're using Android, it's there. If you are using Chrome OS, it's there. I think actually Apple iPhones are also on some version of Unix or Linux. I'm not entirely sure about it because it's a very closed company, but I think it is. Most of the servers run Linux, and there is like top 500 supercomputers in the world, and all of them run Linux. There is not a single one that runs another system. There is a huge ton of distributions available to suit any needs. And these distributions, you can pick any if you have, like if you already are proficient in Linux. Okay, who ran Linux at least once in their life? Oh, good. Okay, so that's kind of half of you. Good. That's actually pretty nice. I think this number grows from year to year somehow. If you like some distribution of Linux, use that. Like you don't have to use Ubuntu. But in this course, we will provide you Ubuntu, and this is a system that, from my perspective, is the easiest to learn if you haven't ever done anything with it. Okay. Now, it's important to understand, if you have never seen a Unix system, how the directory tree is organized. There are no letters like in Windows. There is no like C, D, E, X, whatever. It's all very hierarchical, and it's a tree. So it starts with the root over there. It's always a slash. Like there is no other name for it. And after the root, there comes a lot of things which are just system dependent. For now, you don't really need to know what goes in there. You will learn in time. But the important part here is that your part, the user part, is separate from everything else. So Linux system is very encapsulated. So if I'm, like my name is Igor, and this is my home folder, and I can only access my home folder from this, if I'm logged into the system, unless I have super user privileges. Then let's talk about files and folders. So as I told you, there is this root, and the root has a slash, not just like that. It's because all the folders end with a slash. So root has no name, it's just a root, so it's just a pure slash. But generally, any folder would be like this. So there would be some path to a folder, and it would end with a slash. Everything that is not ending with a slash is a file. It's very simple. There are only two ways of doing it. There are some kind of files, there are some system processes that behave like files, but we're not going to go into that. It's very, it's obscure stuff. You will not need it in this course. Okay, now there are also, like, the paths can be divided into absolute and relative. Like the absolute ones start with the root, so with the slash over here. So for instance, if I have a folder in my home folder, it's going to be in home, Igor, and then in folder. And if I want some relative paths, it just doesn't start with a slash, and that's it. So whatever doesn't start with a slash is appended to wherever I am now in my directory tree, and whatever starts with a slash starts with the root. Also, I think in Windows, I'm not entirely sure, but I think there are the path names and the file names are not case sensitive. So if you have all capital letters in the file, it's going to be the same file as the smaller, the small letters one. Correct me if I'm wrong here, I'm not really sure, but it's not the case here. So a file that is called file name is different from the one that has capital letters in it. And the same goes for extension. Extension is a part of the file name, so you can't have two files that have different extensions. So you can have two files that have different extensions because extension is important here. Okay, so Linux terminal. This is the place where you will spend most of your time when doing any work in Linux, You can still use GUI for many things, but in our course we will use terminal a lot for any building of the code and so on. And at first it might scare you, but it shouldn't, because it's actually pretty simple, and it also allows you to be extremely efficient and very fast. So if you want to say, like if you have a folder with 500 photos and you want to find the ones that have a specific name, it takes you maybe like a couple of milliseconds in a terminal, while if you're going for GUI, you will have to open up the GUI, it will render all the photos, you will wait for half an hour and so on. So it's actually much, much faster, and I hope in the end of the course you will all agree with me on that. And to start a terminal, it's very easy. On a Linux system, you generally just type Ctrl-Alt-T, sometimes it's Win key T, but that's it. So you do that, you're in the terminal, then you can start working with it. Okay, so if we are in the terminal, what can we do in the terminal, right? It doesn't make sense to just open it and look at it. It's not that beautiful. So the first command that you need to know is probably pvd. And pvd is print. Why is it? I'm not sure why it's work. Yeah, that is wrong. It should be work over there. It's a print working directory. So it's the directory where we are. Like that's why I wrote current. I got confused because I always think about it as print current directory. And it will print you wherever you are now in the terminal. So in the terminal, you're always within some folder. This will actually print you the folder that you're in. If you want to go to another folder, you will have to use cd. So it's change directory. You just go to other directory. ls shows you everything that is in the folder. And there are some special folders, as I already told you. The root folder, you probably already remember that. There is a home folder, which is just a tilde. I'm not sure, do you see it? I hope you see it. So this tilde is, it's a shortcut for your home folder. So in case you don't want to type home, Igor, blah, blah, if you type cd tilde, you will be in your home folder. One dot is your current folder. This will be useful a lot for us later. And double dot is the parent folder. So if we want to go one level up, we just go cd double dot. So for example, if let me just make it so that you can see something. Okay, so if I do ls, it shows me all the files that I have in my folder. These are all the files. It's a bit cut off. Just change one thing. Okay, better. Right, so if I want to, like now I am in home Igor over there. And if I want to go to another folder, I just go cd and say, I want to go to this folder remote data. If you don't see anything, shout, because you have to see it. It's a bit unfortunate that it's on the top of the screen, in the bottom of the screen, but we're going to have to deal with that. So if I go to remote data, now I can do the PWD, and it shows me that I'm in the remote data. If I want to go up, I just do cd double dot, and I'm back in home Igor. And that's basically it. So it's very simple. And the moment you remember how the tree is organized, it's very easy to navigate. There's going to be a lot of live coding in this course. So I hope, I believe that it's not interesting to just listen to me. I believe that it's much nicer if I show you something and you can ask me questions live. What will happen if I do this? What will happen if I do that? And for now, maybe it's still not very interesting because you have just 3 commands for now. But when we go to C++, it's going to be much more important for you to just fire away and ask questions. What will happen if you type this? And what will happen if you run that and that and so on? I think it's important because you can ask questions and you don't have to do it yourself. I will do it for you. Good. So you can run a lot of commands. So these 3 commands that we started with are just some commands. They're all just programs written in C or C++, and usually, you can run them by executing them. So executing them means just you type them into the terminal. The terminal knows how to execute them. You can provide a path. You don't have to. Some programs. So there are some paths defined in a Linux system where it will search for programs. So for instance, ls is actually placed in user include or like user bin, and it just knows where to search for it. But you can type the command over there, and it will just execute this command. You can also provide some options to this command. For instance, like help. Help is a very important option. Use it a lot. So if you don't know how to use a program, use help. Because it's written, it's not always well written. Sometimes it's written in a way that it tells you all the options instead of saying you how you would want to use it. But it should be, at least to some degree, helpful. And then you can provide some parameters. So for instance, if the program cd had a parameter folder to which we want to change. That's the parameter. So just to show you how help looks, if I have ls and I type help, it will print a lot of things here. And as I told you, it can be a bit daunting because it's a lot of information, but at least it tells you what it does. So it's something. Right. Okay. It will also tell which parameters it takes and which positions and so on. So use help. Yeah, it repeats me. Okay, so if you're not satisfied with help, help should be generally a short help. There is a manual program. It's a program that you give something to it, and it creates you the whole text user interface in your terminal, and shows you what's going on with the program. What can you do with the program? And it's very exhaustive. Like, it will tell you everything about the program. So for example, again, let's do this with man, and it's a bit better interface, and you can navigate it. There's like all the options that you can pass to it, and so on. Not all the programs have man, but most of them have help. You just have to figure out which one you want to use on a particular program. Just try both of them and figure out which one is more readable for you. Okay, a very important thing is you don't have to type everything on your own. Like, I know that some people are really good at typing. I suck at typing. Like, I always make mistakes, and that's why you should use tab. Tab completes everything. So if I want to, for instance, let's see what I have. So let's say I want to go to teaching folder, and I just type T and I press tab. It shows me the possible completions. There can be a couple of them, and if I press tab again, it will cycle through them. And let's say I want to go to teaching, so it will be teaching for now. And if there would be only one option, so if I type not TE but TEA, then it becomes unique, and I just need to press tab once and it completes it. If there are some issues, it will beep at you. It doesn't like it when something is going wrong. So top tab shows you all potential matches. One tab completes whatever you want to write. Teach yourself to use tab often. It will save you a lot of time. At first it will be, I know a lot of people somehow don't do it from the start. I don't know why, but try to teach it to yourself. Also, I urge you to try it on your own. So just after the course, fire up the terminal, navigate 2 minutes in it. You're going to be fine afterwards. Okay, now that we know how to move around in the terminal, we also want to know how to create files, how to create folders, how to copy and move them, and so on. And it's all exactly as you would expect. So there is a makedir command. It just creates a folder. If you put -p, it can create a link of folders. So in case I want to, so let's create a makedir hello dear, and so yeah, it should be somewhere there. Yeah, this here it is. And if I want to create like a couple of directories, if I just do makedir, for instance, hello dear test. So like it's a long chain of directories which are not there. It will tell me that there is an error and it cannot create a directory because there is no such file or directory, because there are not enough directories. If we pass -p, it will just create them and they are there. You can remove everything. So that is a very dangerous command. This is like the ongoing joke in Linux community where you just have to rm -rf / which basically means remove everything in your root, so everything that you have on your PC. And it's you have to remember, it's not like on Windows. Whatever you remove with this command is gone forever. There is no trash. There is no such thing here. So if you remove something, it's gone forever. So be careful with using rm. If you remove something from the GUI, it's usually done in the way that it's actually moved into a trash, and you feel like it's removed, so it doesn't actually use rm. But if you're using it from the terminal, beware, and especially when you're using this command -r. -r stands for recursive, and recursive means it will just go through the folder where you want to remove things. If it will find another folder, it will go into it, remove everything from there, and remove the folder itself. So it goes like, it removes everything that it finds. If you also pass -f flag, which is force, it will not ask you if it tries to remove a file that is protected. It will usually ask you, like, do you really want to remove this file? It kind of looks important. Do you really want to do it? And if you say yes, it will. But if you say no and you find out, oh, I didn't want to remove all my system, then it's kind of, it will stop. But if you pass -f, it will say, well, whatever, you know what you're doing, so let's just remove everything. Okay, so beware with that. Copy works in the same way. It's not as dangerous though, but it also has this -r flag. To copy a folder, you need to pass -r flag. It will actually complain if you try to copy. So if I want to copy my hello directory into hello directory copy, for instance, it will tell me omitting directory. So I need to pass -r, and then it knows that it has to recursively copy all the files in the folder, and so on. So recursiveness works exactly in the same way. Right. Hopefully for now everything is kind of intuitive and clear. Move works in the same way. The only slight difference here, you don't have to pass -r. Somehow move knows how to move folders, copy doesn't know how to copy them. I don't know why that was done. There probably is a good reason for it that I can't think about now, but you can just move a folder. So if I now want to move my hello dear into hello dear move, I just type move and I'm done. And you can do that with any files and so on. It just works. Good. So hopefully that is clear. The cool part, what makes it very efficient, is the placeholders. So as I told you, like if you want to show, like say all your photos from summer 2015 in your folder where you have thousands of photos and they're all named by date, for instance, you don't want to type all the names of all those folders. You don't want to see them all on their own. You want to kind of copy all of them. To do that, you need placeholders. So placeholders means that there is a sign that tells the terminal that any character can be instead of it. And for instance, the star sign is, it stands for any set of characters. It can be one character, many characters, so it can be everything. The question mark stands for one character. It's any character, but it's a single character. And then you can have ranges of characters. So like AF range means that it's going to match any character in this range from A to F. And if you want to match everything but some range, you're going to use this, I have no idea how to name this sign, the hat, let's call it hat. So the hat symbol to match everything that is not in the range. And it works with everything, with ls, rm, move, and so on. So I have here those PNG files. Hopefully you see them, refs. I have it from some paper that I've written. And the cool part for now is that they have these numbers. So I can show this thing for you because they have those numbers. I didn't plan that, but okay. So if I just try to ls all of them, it will show me all the options. But let's say I want only the ones that start with an 8, for instance. So I can just type 8 star, and it will show me only the ones that start with 8, for example. Or if I want, say, only 7 and 8, then it's going to be only the ones that start with 7 and 8. And again, you can put it anywhere you want, and so on. So feel free to experiment with it. It's very, very, very useful. I can't stress this enough. You will use it a lot in the course. And if you're fluent with that, you will get much more efficient with anything that you do on your computer. Good. If there are any questions, fire up. All fine? For now, everything is clear? Good. I will skip the example because we do it live, but you will have a slide for that if you don't want to do it on your own, although I suggest you to do it on your own, but you can always just look at a slide and kind of, okay, this is easy, I know how to do it. Good. So there is an important concept that we will kind of bump into again and again is the input and output channels. So they're called channels. It means that you can kind of put something into a channel and you can read something from a channel. And there is a single input channel, it's std_in, and there are two output channels, std_out and std_error, which stand for standard output and standard error channel. Everything that the program writes in the terminal, it writes because it writes it into some channel. So it writes it either into std_out or into std_error. Everything that you pass into a program is there because you actually write it into std_in and the program reads std_in. So this is an important concept, but if you remember this is all you need to know about it, kind of. And we're going to use it a lot when we go to the C++ part. We will also use that concept a lot. You can redirect std_out. So if you want to run your command, but you want to store everything that this command runs into a file, instead of outputting it to terminal, you can use these signs, like this arrow signs, or like bigger, smaller. And you have to remember that std_out is channel 1, std_error is channel 2. And the syntax is a bit obscure, but you just have to remember it, I guess, at this point. So redirecting std_out can be done like this, or like this. It can also be done with one of those signs. Again, try it out. It's not too dangerous. For instance, like this command tells, I want my first channel to be redirected into the out.txt. So for instance, let's do again our small examples. So if I do ls, it shows me a lot of things, and I don't want to see them in my terminal because it's a lot. So I just want to redirect it to ls.txt, for instance, and you see that it doesn't output anything. So it just shows me the command that I ran. And the actual output is in the file. So if I now just open it with anything, any text editor, it's going to be, so it's there. This is my output of my ls. Okay. Good. You can also redirect only std error, for instance. If you want all the errors to be stored in one file, you just use 2 instead of 1. So that should be pretty simple. The only kind of really non-intuitive part is if you want to force everything to be stored in the file. So if you want to redirect both std_out and std_err, you have to use this syntax. So you have a program, you redirect it to out.txt, but this just redirects the std_out. The problem is that you need to pass this obscure thing, and it always has to be passed in the end. If you pass it before, it won't work. So that's that caused a lot of frustration for me when I was learning it. Like I was not, like, why is it not working? So you have to pass this thing in the end, it's important. And then what it does, it redirects the std_err onto std_out, and then it puts std_out into the out.txt. That's all it does. Good. You can also redirect them into different files, which is something that can be useful if you have a program and you try to debug it, and then you want to find out what happened, and so on. Good. We can also work with files. We can show what is the content of the file. For that, we have 3 general programs that can be run in a terminal. It's more, less, or cat, or you can call it cat, I guess. I don't know. What it does, it just outputs the contents of the file into the terminal. So remember, we created this ls.txt file, and if we just cut ls.txt, it's going to be shown right there. Good. Now, there is also a command find. Every time I use it, I have to look up how to use it somehow, because it has a lot of options, and it works, but not very reliably. I still think it's an important program, but it will take you some time till you get accustomed to using it. But the most important, I think, if I would pick one favorite program of all those typical Linux terminal programs, it would be grep. Grep is insanely powerful. Like it's the program that you might want to use like all the time. If I want to find out, for instance, where like if there is anything that has a number 8 in it in my ls file, I just use it with grep. Actually, let's do the proper grep. So grep ls.txt. No, wait, the syntax is okay. It's 8 ls.txt, and it shows me everything that matches 8 in this file, for instance, it even highlights the matches. So if you have a huge file and you want to find everything that contains a word that you're interested in, like error, for instance, if you have like a huge output of your program and you want to find what went wrong, where is the error, you can use this. You can just use grep, and you can use it with everything. We will come to that in a bit. So grep is like the program that defines the Linux console for me. You can chain commands, so it's very useful because you don't need to store something in a file to grep it, for instance. You can just chain it and grab the output of it. So for instance, if you just put a semicolon after every command, it's gonna just run the sequence of commands. That's it. It won't stop when one command fails. It will just keep running. If you want the commands to stop after they failed, so if, say, you tried to, I don't know, make directory and it didn't create a directory really, and you want to stop your execution after that, you use this end symbol. So it just tells you you only can run the next command after the previous one succeeded. So if it failed, you cannot do it. And again, one of the most important parts of the Linux terminal is piping. So this is the piping symbol. It means that feed the output of this program onto the input of the next program. So the command 1 will write something to std out. This will get it as std in. It will write something to std out, and this will get it as std in. And it's very useful with grep. So I showed you how to use grep with a file, but I can just use grep like this. So I ls something, and then I grep, let's say, whatever I want, like after. And it will show me only those results. It will not show me everything. It will only show the ones that match. For now, you kind of have to believe me that it's useful because you're not actually using it right now, but I believe you will use it in the course. If you start using it, you will find out that it's actually useful. So piping is important. You can also cancel any running command. If you have a long running command, if you run your program and it never stops, it happens a lot, and you're tired of waiting and it takes up your terminal and you don't want, like, you want to go home and you don't want to do it anymore, you just type Ctrl+C and it breaks up the command. It sends a kill signal to the process and it stops it from running. You can also just kill any process. There are many processes in the system, and the standard way to do it is kill. -9 means send a kill signal. There are many signals that you can send. For now, just remember kill one. It's, I guess, for this course, the most important one. You can also kill everybody or everything, every process that you want. Like if you have a process and you want to kill everything that is related to it, you just know its name, you kill all by name. But I personally don't use kill and kill all because there you have to know the process name, you have to know the process ID, and it's kind of annoying to know. So what I use is this htop. Htop is also one of my favorite programs, I guess, in the terminal. It's not pre-installed on the systems. The one that is installed is top, but you can easily install htop and it's so much better. And it looks kind of, so if you want to impress somebody while you're on the commute in the train and you just want to show up a cool terminal, it kind of looks like this, like, and everything is moving and all those processes and so on. And at first, again, like it might be a bit weird, but it's very simple. Like you see all your cores of your processors, you see how much memory you have. Swap, let's forget about that. You see all the processes and you can sort them, you can find them and so on. And if I want to kill a process, I just type F9 and enter, and that's it. And the process that is selected is killed. So it's very easy, and I would suggest to just use that and use like you have to know that there is a thing called kill, and you have to know that you can use it. It's not often that you have to use it. Usually it's fine to use htop. Good. And another thing, like everything is recorded. So there is a history of your commands, and you can navigate it. So for instance, we've done a bunch of commands, and if I just keep pressing arrow up, it will cycle through all the commands that I've been running while showing it to you. So it's never gone. Like if you want to run the same command over and over, you can easily do it. You don't have to retype it, which makes it more efficient. And even a better thing is Ctrl+R. So if you press Ctrl+R, it allows you to search through history, which is also nice. So if I want to, like, let's say I want to do the cut command, and I don't remember, was it like fifths from the start, tenths from the start? I don't know. So I just type Ctrl+R. It shows me this BCK, backward inverse search, I think. But you just start typing cut, for instance, and it matches it. And if you are not satisfied with this match, you can keep pressing Ctrl+R, and it will show you all the other commands that start with it that you have run over the history of your terminal. So I believe it's very useful. You can also just see what commands are stored in the bash history, and bash history, I think by default, is 200 commands big. You can specify that, but we're not going to go deep into that. You can search for it on the internet. Again, like also one more thing. Searching is important. Like last year courses, we always had the problem that people don't want to search on their own. So they just want to come and kind of have it solved. I understand the urge, but I feel you need to search a bit on your own. So if you don't know how to do exactly something, try at least like spend 10 minutes on looking for it. If you can't find it, come to me, we're gonna figure it out. If you found something and you're still unsure if it's actually the way to do it, also come to me, we're gonna figure that out. But searching is important. I think it's one of the corner case skills for any programmer, like searching for information. You're gonna do things that you don't know how to do, you have to know how to search for them. And there's a lot of information about this. Good, so I was speaking about installing software. So for instance, htop is not installed by default on the system. And if you want to install it, it's easy to do. So on Windows, you generally install stuff by browsing the internet and trying to find some weird executable file that you will download, and then you will run and it will install it somewhere and you have no idea how it does it, and so on. It's a bit like that here, but much better. So you still don't know exactly how it installs, but you know exactly where it installs from. There is a bunch of repositories already shipped with the system, and they contain a lot of software. So a lot of software that we will be using is already shipped in those repositories. And to install something, you just need to go to the terminal and type the sudo apt install and then a program that you want to install. It can be any program like htop, like any compiler that we will be using, or anything else. It really contains a lot of stuff. And the important part is you always have to do the sudo apt update before, because this actually goes through all the repositories and fetches the list of all packages that are available. And the cool part here too is that tab still works. So if I type sudo apt install and then I remember that it should be something with like htop, like ht, like I type ht and then tab, and it shows me all the options that I have to pick the one that I want to install from. You can also search for something. If you know what program you want, but you don't know which package it belongs to, you can just use apt search and look for it. And it also works for any library. So if you want a library, we will come to that later. But if you need to install a library system-wide, you just do the same thing, but you start with lib. I forgot to tell you, sudo means that you are a super user. Sudo is kind of dangerous because it allows you to modify all those files that were on the system side. So not in your home folder, but on the system side. And whenever you type sudo, it will ask you for your password. And if you pass your password, it will allow you to modify those files. So whenever you install something, you're actually installing it system-wide. So that's why it will ask you for your password. Good. Okay, so C++. I think at this point we are done with the Linux terminal. So now we can move on to C++, because that's basically all that you need to know about Linux terminal for this course. Like there is nothing else. Like with this tool set, you're going to be really well off. This is like the tool set that I'm using every day at work, and that most of the people that I know use. There is not really much more to it. Okay, so C++, we won't teach you everything about C++. In this course, it's not about teaching you everything about C++. If this is the whole C++, this is the amount of C++ you will learn here. And I think it's very important because C++ is dangerous. Like you can do everything with it. Like it has all the control of you can have all the control of all your hardware on your PC if you know what you're doing. The problem is that usually you don't know what you're doing when you start, and it's very easy to shoot your leg off with it. So this course will focus on the fact that like this will be simplified C++. So we will not start with the hard part. I will try to actually teach you modern C++, which is easier to understand and where it's harder to make a mistake. So it will be a very constrained amount of C++, but it's the amount of C++ that is used by, say, Google and other, like, say, companies in the Valley. That is what people consider now to be a separate modern C++ language. So this is what we're going to be learning. And just for reference, Bjarne Strostrup I'm not sure I pronounced his name correctly, but he's the guy who wrote C++ initially. He's the guy who came up with C++. And he's still very active. He's an relatively old person now, but he's very active. He always does a lot of talks at the conferences and so on. And he is actually, so he said this phrase that there is a smaller and cleaner language within C++, and this is what everybody is kind of trying to find now. And after working with C++ for a while in companies, at the university, and so on, I will go into the direction of only teaching the modern C++. We will get to the older parts later, but only when you're comfortable with doing anything with it. Okay, let's start with the basics. Where can you write code? Like, what can you use to write code? And there are a bunch of options here. So you can either use an IDE, or you can use a text editor. There is a bunch of IDEs. So for instance, C-Line is one by JetBrains. It's actually really well made. It's a complicated one, but it's well made. There is a classic 2 variants, Qt Creator and Eclipse. You can use both of them. But I would suggest you to go for just a modern text editor. So modern text editor means that it's a text editor that is done for programmers. So it's basically, it has a lot of tools to make sure you can code in it, but you will still understand the process. The problem with IDEs is it can be a bit like magic. You just do something, it kind of works, and you try to please it. Like, okay, I will give you this option. You still don't work. Maybe this option, maybe that. And then you just do it randomly. You don't understand what you're doing. I would urge you not to do it. I would urge you to understand what is going on, because it will save you time eventually. My personal preference is Sublime Text. I really like it. All the examples that I will show you will mostly be in Sublime Text, maybe sometimes also in Vim, but mostly Sublime Text. There are many other options. You can use like Visual Studio Code, Atom, and all of these are free. So at least for students, I think the IDEs, I think this one is free for students, this one is free for students, everything else is just free. If you really like Pain, go for Vim and Emacs. If you ask it on the internet, hey, which editor should I use? People will say Vim and Emacs. It's hard. It has it's an editor that is basically an operating system. To learn it is another course and maybe another life. I don't know. Some people do it. I wouldn't suggest you doing it from the start if you're not a fan of one already. Good. So let's start with the hello world. This is like the most basic program you can write in C++. And just to make sure that we start with something that actually runs, we will right now dig into it a bit, but that's all it does. So basically what you see is it just tries to output in some way. We will come to that right now. It will just wants to say hello world in the terminal, and that's all it wants to do. Good. So let's start with breaking that up. Like, let's understand every line of that small program for the start. And we start with the comments and white spaces. They're not important in C++. C++ throws them away the moment you pass it to the compiler. The compiler looks at it and says, okay, this is not important. And everything that starts, so every line that starts with / is a comment. So for instance, this is a comment. And also the ones that are encapsulated in these things are also a comment, like this. And again, like an editor that supports highlighting, code highlighting, will show you that it's a different thing. It will show you it's grayed out. It means that it's a comment. Okay. Because the white spaces are not important, all of these are exactly the same to C++. C++ will not see the difference between these two. They're only for us. So we can format our code the way we want. C++ just reads the number of, like, it parses the code and it doesn't care about the white spaces. So if you put the return right on the same line, or you skip a line over here and put return here and so on, like, it doesn't matter. Like, it will still compile and it will still be the same program. At this, I want to say that having a good code style is extremely important. Like, I can't stress this enough. don't just write any code in the way it just looks okay. Write the code that looks well. Like you're writing the code to be read. Code is much more often read than it's executed, really. Like, so it's, if you write something and you go away for 2 months, you will hate yourself when you come back after 2 months and you haven't styled your code well because you will not be able to read your own code. I've been there many times. I don't want to be there anymore. That's why I adopted the code style. And that's why a lot of people do it. What we will, like, you're either lucky or unlucky, but you have me, and I'm going to force you to use the style code, like style sheet. And we're going to be using the Google style sheet. It's a well-defined style sheet used by, surprisingly, Google. And they open source the tool to check your code against their style sheet. And some reasonings at first may sound a bit controversial, but if you follow it, it will make your code cleaner, and it will kind of forbid you making mistakes. Right. Also, there is a program, like there is a bunch of programs that help you write readable code. One of them is Clang format. Clang format, it just styles your code. So for example, let's do just a sec. Okay. Good. So you see that. That's nice. Right. So if this is a program, and let's say there is a bunch of things that are just wrong and so on, and it's all looks weird. For instance, my editor knows how to use Clang format because it's kind of baked in now. So if I just select everything, I can style the code with it, and it will pick a style, and it will like adapt the style to fit the code. Well, maybe we need some more code to showcase this. Then let's. Okay, we're going to see that a lot. Like I will use it a lot during the live demos. So the idea is that there is a tool that will format the code for you automatically. The CPP-lint tool is provided by Google, and it will tell you what errors are you making with respect to the Google style sheet. And in the slides, I will use this tag over here, Google style, whenever there is a suggestion made by Google style. So I will try to reference it whenever appropriately. You don't see it here, but it's for your reference afterwards. When you're looking at the slides after the lecture, there is I try to link everything that I'm using. So if you want to read the first, like the source, like the actual style sheet, like it's a web page done by Google, you can read it, you can find all the information you want there. The links should be kind of always in the bottom of the slides. Okay, so you probably are now confused about all this main and so on, because maybe it starts a bit too fast, so let's focus on main. Every single C++ program starts with main. There is no C++ program that doesn't start with main. It's a legacy to C, but that is the way it's done. And main is a function that returns a value. So that you can see this return, it means that it outputs a value somewhere else. So if I would compile this program and then would run it from the terminal, it will return an error code. And it's kind of the standard in Linux is that error code 0 means okay. Every other error codes are reserved for all the errors that you want to do. So if you want to, let's say if you had to read some folder in your program and the folder is not there, you can exit your program with error code 1. And if something else happened, you can exit it with error code 2. And this way you can kind of decide how to discriminate between the errors that your program throws. So in this case, if you return 0, it means that the program finished without any errors. If you return any other number from 1 to 255, it means there was some error and the error code is this. But the main program looks like this. So this is like, it's not the smallest program that you can write in C++, but it's the smallest sane program that you can write in C++. It's as simple as it goes. You just have one function, you just have one return, you're done. Good. You've probably seen this include thing on the top of the file. It allows us to include other files into our file. We will talk about it a lot in the course, but for now you just have to understand that whatever is in this file, whatever it's named, it can be named in arbitrary way, but usually it either has the .h or .hpp or no extension at all. But it can be any file really. And you can pass this file, and what it does, it just looks for this file, takes all the contents of this file, and copies it into your file before it gets compiled. So you don't see it, but it happens in the compiler. I mean, you can see it if you want, but you generally don't. And the idea is that if you want some implementation in another file that is big, and you want your main file to stay clean and small, you just have the implementation in that file, and you include it here. But we will talk about it much more. For now, it's just important to understand that this file gets copied into your program. Again, I/O streams. So we've talked about them in the console, and they're the same output and input streams here. So the C++ I/O streams map exactly to the ones that we had in the terminal. So you have std_cin, which maps to std_in. There is std_cout and cr that map to std_out and std_err. And you need to include I/O stream, so input, output, streams. And this basically, it's a library that has all the implementation you need. So it will just copy all the implementation into your file before it gets compiled. And that allows you to use this syntax like this. So you can read something from the console, and you can write something to the console, and it's going to behave exactly like all those programs that we've seen before. As a matter of fact, all those programs are actually written like that. So they actually use like streams or other ways to communicate with the terminal, but they still use the same input and output channels. Okay, also, like, it might be a bit confusing, this thing, std_endl, like endl is end line. So if you want to end your line, you just type that in. For now, at the start, there's going to be some things that are just, you will just have to believe me that it's done like that. But we're going to dig deeper afterwards. I just want to give you something that you can start using basically from today on. All right. Now, how do we compile our hello world? C++ is a language that needs to be compiled. So there is a compiler, and this compiler is your friend. Like it will look at the code that you've written, and it will try to create a binary from it. Because we people, we understand text. Like we read text, and that's why we write programs. The programs are written for other programmers to read, or for us to read. They're not written for the computer, so make sure they're readable. It's very important. But the computer on its own, it understands just the machine code. So we need a compiler, which is just a translator. It just takes as input our text and translates it to the machine code, basically. And then the compiler also knows how to what is correct, what is wrong, so what fits into the specs of C++, what doesn't. So if we do a mistake, it will tell us, nope, you can't do it. It actually is very helpful, because otherwise we would not know if it worked or not. So if compiler complains a lot, it's actually doing it for your own good. It's a good thing. Sometimes the error messages can be a bit obscure, but I think it's still very helpful. Now, there are a bunch of compilers. There are basically, as far as I know, there are 3 like major compilers. One of them is Microsoft Visual Compiler, Visual C++ Compiler. It's exclusively on Windows for now. It's a good compiler, it's a huge compiler, but it's in Windows world. And there are two big compilers that are available for all systems, like Macs, Windows, Linux, obscure systems, whatever you want to name. And these are kind of the classic one is GCC or G++, and it's a huge compiler. It does everything. It's kind of the standard. But now there is a smaller and easier version. It's called Clang. This is the one that I urge you to use in this course. The error messages are a bit better, and it generally is a better package from my perspective. But anyway, on your system, they usually map to... So the compiler, again, is just a program in your terminal. Like it's in your system, you can invoke it in a terminal, and you just give it some input, you give it some parameters, and it will provide you some output. It will create you something on the output. And usually if you have a Linux system and you have a compiler there, it's mapped to the C++ handle. So it's not, it can be, you can just use, say, Clang, for instance, instead here, or Clang++ or G++, which are the actual names of the binaries, but this C++ maps to whatever is defined as a compiler in your system. And we are going to be using the C++11, so you have to pass that we are using, the standard is C++11. Now, we pass the -o hello world, which is the name that we want our program to have in the end. And we just pass in the file that, so the parameter to this function is the file hello world CPP that we have just written, and then we can just run it. So instead of just kind of talking about it, I can probably show it to you. So now we have this, this function over here. We can write this IOStream thing, and okay, I'm lazy. So this thing is also kind of, it's a return character, so it will skip the line to the next line. That's it. That's all it does. So no magic. Okay, cool. Now, this thing I can compile. So I need to, I think I saved it into a temp folder. The temp folder is an important folder. It's the folder that gets cleaned on every restart of your system. So whenever you restart your system, everything you had in temp folder gets deleted. So it's perfect for this matter, where I can just show off some things and then it gets removed. Okay, so we have this this test CPP over here, which is our program, and we can just type C++ minus std C++11 minus O hello world, and give it test CPP. You see that, right? Or should we close some shades? I don't know. There were shades before, now there are not. Maybe there are. Okay. So is it seen or not? Like, everybody sees it? Good. So if we just run it, it does something for a short while, and it has done something. Now let's see what we have here. So you see this bright green, hopefully you see this bright green thing over here. It's our executable hello world. So if we now run it, you run things like this, which means that it's in the current folder, and this is the binary that we want to run. So we run it, and hooray, it types hello world. It's very simple, and now we're great C++ programmers, right? But that's basically as simple as it gets. So that's how you compile any simple program. Like, you can write anything in this file, and you will compile it in exactly the same way. And this is actually how you will compile your first homework eventually. Then we will move on from here. You don't have to compile everything from the terminal like this, but for the starters, I think it's important to compile at least one program from the terminal. But that's it. So now, if I say do something like this and like this, I wanted to show you that the Clang format works. So if I just No, it doesn't. Why it doesn't work? I don't know. I think, I know why. Because there are many styles that it supports, and it's not the correct style, which is a good thing. I need to make sure that you have the correct style. Okay, good. But anyway, you can do it automatically. You just have to figure out how. Right. So, any questions to this? Do you want, like, do you not understand how something of this works, or if there are any questions to this now, ask them now. Yeah.
std error, that's the error stream, right?
Yes, it is.
But why is the hello world stream the error stream and not the normal output stream?
That is because it's gonna be exactly the same. So if let me just first show you that it's gonna be exactly the same. The reason I used it is it's just a habit. So generally std error in practice, I will not go into details because it's deep, but it's a bit faster. So if you write high performance code and you want your logs to be output and you have no other way of doing it as streams like this, there are other ways, but if you don't have any other ways, you usually use std error because it's faster. It will not get so sometimes if you write std out, you can write actually 3 lines and then they get printed to the terminal because they get kind of buffered and then they're flushed. std error doesn't have that. It just outputs whenever you write to it. So it's a habit of mine, but usually you shouldn't do it that way. Like you should write whatever is an error or should be error message, write it into the error output and into the error stream, and whatever is not an error into the output stream. So it was a legitimate question. Thank you. Anything else? So, okay. Good. Where is my lecture? All right. How much time do we have left? So we started at 10, and now so we kind of have 10 minutes more or less, right? 15 minutes. I think this is actually a good place to break our lecture, break it up, and the other part I will just tell you tomorrow. So now we have like 10, 15 minutes of time. If you have anything that was not clear, we can discuss it now. I can explain it better and so on. If not, you're basically free to go. I think that's the way we're going to do it now. So in case you have any questions, fire up. Like I have all the terminal, the simple hello world program, the great hello world program up and running. So if you want to change something there to see how it behaves, or you don't understand something that I explained, ask it now. If not, we're done. So, okay, I see nobody has questions, right? Okay, cool. Like, also, feel free to just come by if you don't want to ask it like out loud. Just come by afterwards and ask it privately. No problem. Thank you.